Hi, welcome to Math for All, where everyone can learn more about math. We've learned a ton about functions, and today we will investigate some of what we call parent functions, and where we can put some numbers to move or translate those functions. We will learn the parent functions of y equals x equals x squared, and y equals the absolute value of x. This lesson emphasizes graphing, so if you're a visual learner, you can enjoy this one. Let's get started. First up, the function of y equals x. This function has every point that has the same x and y value, such as 0, 0, 1, 1, -3, -3, etc. You can see it makes a nifty line that cuts through the middle of the first and third quadrants. Next, y equals x squared. I can make a table of values to see what's going to happen with him. When x is 0, y is 0. When x equals 1, y is 1 squared, which is also 1. This seems like it could look like our previous function, but not so fast. When x equals 2, y is 2 squared, or 4. And when x equals 3, y is 9. Interesting. Let's get some negative numbers now to see what's going on before 0. If x is -1, y is -1 squared, and -1 times -1 equals +1. Similarly, if x is -2, y will be +4, and -3, 9 is also on our graph. The parent function of y equals x squared is a lovely parabola that sits right at the origin and looks like a huge smile. The last of today's parent functions is y equals the absolute value of x. Remember that absolute value turns everything inside positive. So x equals 0. The absolute value doesn't change it, so the y will also equal 0. When x equals 1, still no change, y equals 1. X equals 2, y also equals 2. That looks a lot like the parent function of y equals x so far, but let's plug in some negative x values. X equals -1. The absolute value makes it positive, so the y will equal 1. X equals -2, the y equals 2, and so on. Absolute value graphs have a V shape, and the parent function is a perfect V with the vertex at 0, 0. Beautiful. So now you know these three parent functions. Let's put some numbers around them to move them around a bit. Say we have the function y equals x plus 3. What does that plus 3 do? It moves every point from the parent function up 3. We say that it has a vertical translation of 3, meaning it moves it up 3. Here is the rule for vertical translations. When a number is outside of my parent function, like y equals x squared minus 4, or y equals the absolute value of x, then plus 7, that tells me that I have a vertical translation by that amount. Now, we will put a number right next to the x, where it's in parentheses with its buddy, the x. This isn't really applicable to the y equals x parent function, so we'll skip to the others. If I have y equals x plus 4 in parentheses squared, that plus 4 does not move it up 4. How I think of it is that it is buddies with the x, so it will move it side to side along that x-axis. But here's the tricky part. X lives in what I call opposite land, where you change the sign of whatever's next to it. This +4 will move the parent function backwards 4, or to the left 4. This is shown on the graph and can be tricky, so please accept this and remember it. Here's another one. Y equals the absolute value of x minus 2. We know that we have a horizontal translation because the 2 is hanging out with the x, so it will move side to side. There's a -2, and x is in opposite land, so that -2 will move the function 2 forwards or to the right. I'll quickly show you with a few points how it works. For this function, when x equals 0, y equals the absolute value of -2, which is positive 2. When x equals 2, y equals 0, and when x equals 4, y equals 2. You can see that my v parent function did indeed move forward too. Congratulations on examining the 3 basic parent functions and seeing how those numbers move them around. Just remember that x lives in opposite land and you will be on the road to success. Keep coming back to learn more about math.